Assalamualaikum warahmatullahi wabarakatuh. This is an examples of compressor, and now the substance that going through the compressor is R134A, which we consider it as a liquid or steam. Okay, so for this problem, R134A enter an adiabatic compressor. So if we look at this word adiabatic, so it means that the heat is equal to 0. There is no heat in and there is no heat out. And the pressure that enter the entrance of compressor is 100 kilopascal with the temperature in negative 24 degrees Celsius. And as we know, the function of the compressor is to increase the pressure. Therefore, the pressure will be increased to 900 kilopascal and temperature increased to 60 degrees Celsius. There is work input here, and there are also a volume flow rate. V dot is equal to 1.35 meter cube per minute, and we convert this unit to meter cube per second. Neglecting kinetic and potential energy, determine the mass flow rate m dot and power input to the compressor. So to solve this problem, first thing first, we have to be very careful because this problem involving R134A, which is liquid or steam. And as I mentioned in my previous lecture, that for liquid or steam, we have to check the phase at every state. So for the compressor, it has state 1 here, and we have state 2. Okay, to solve the problems in liquid or water, we have to know the phase for each state. Okay, so for m dot, we know that the formula given here is V dot is equal to m dot multiplied with specific volume. V dot is constant. V dot in is equal to V dot out. So we can choose either one. Alright. So to find m dot, we already know the V dot, but we must find specific volume. Okay. To find specific volume, we have to refer to the property table. Okay, so we have to check the phase for each state. First thing first, we check at state 1. Here, state 1 given pressure as a 100 kilopascal and temperature is minus 24 degrees Celsius. So these two properties are intensive property. Therefore, you can choose to sketch TV diagram or PV diagram. So I sketch TV diagram, and this is constant pressure line. So I refer to table A12. Okay, and I find out that the T saturated is minus 26.4 degrees Celsius. Given here, temperature is minus 24. Sorry, T saturated here is minus 26.4, but given here is minus 24 degrees Celsius, which is greater than T saturated. So from this pressure line, we know that the location of the point is at the superheated. Okay, so the phase is superheated. Okay, so if the phase is superheated, we must refer to table A13. So in table A13, okay, you have to find out the temperature between T saturated to minus 20 degrees Celsius, and we do an interpolation. Okay, from the interpolation, okay, I get specific volume 1 as 0.19473 meter cube per kilogram, and enthalpy is 236.34 kilojoule per kilogram. Okay, so I already get V. Alright. Next, I want to know what is the phase of state 2. Therefore, I do the same procedure as state 1, which is I sketch TV diagram. Okay, I look at table A12 at 900 kilopascal, and then I find out that the T saturated at 900 kPa is 35.5. Given here is 60 degrees Celsius. So 60 degrees Celsius is greater than T saturated. And we know that the phase at state 2 is superheated. So from if table A13, okay, I refer at P is equal to 900 kPa and temperature 60 degrees Celsius, and I get V2 is equal to 0.026146 meter cube per kilogram, and enthalpy is 295.15 kilojoule per kilogram. Okay, so right now I can answer the question. Okay, the question is, what is the mass flow rate? Okay, the mass flow rate is V dot over specific volume. I can choose V1 or V2, either one. So here I choose V1. Okay, and I know that V dot in meter cube per second is 0.0225 divided by V2, that is 0.19473, and the value is 0.1155 kilogram per second. Okay, next is work input. So from SFEE, since there is an adiabatic compressor, so there is no heat. Okay, so at the inlet we have W dot in plus M dot H1 is equal to, there is no heat, there is no work out, so we have here M dot H2. Okay, so W dot in is equal to M dot H2 minus H1. Okay, we insert all the values and we get 6 dot is 6 dot, sorry, work input as 6.7925 kilojoule per second or kilowatt. Okay, thank you.